Okay, Year 7, welcome to your video tutorial on adding and subtracting fractions. Okay, fractions with the same denominator can be added or subtracted together really easily. Let's have a think about why that is. Well, because they have the same count of parts that make up a whole. This one has 8 parts that make up a whole here. This one has 8 parts that make up a whole. So say I've got 2 pizzas and they're both divided into 8, and one pizza has 3 slices left and one pizza has 2 slices left. I can easily work out that there's 5 slices out of 8 because my first pizza is out of 8 parts and my second pizza is out of 8 parts. Okay, so it's going to be 3 over 8 plus 2 over 8. It's really straightforward. But we come into a little bit of a bother when the denominators are different. Imagine if I had a pizza that was cut into 3 and then a pizza that was cut into 4. I have 1/3 plus a quarter. They have different parts. How much of a pizza do I have? Do I go with the 3 or do I go with the 4? Or how in the earth can I compare something that has 3 parts that make up a whole with something that has 4 parts that make up a whole? Well, the answer is I can split it into even more parts. So I can take that one that was 3 and I can take that one that was 4 and I can split it into more parts. I can find a number that 3 goes into and 4 goes into and divide the pizzas up so that they have the same amount of parts. I'm not changing the size of the pizza. I'm just cutting them so they have the same amount of parts. If I've cut them into 12, this one has 12, and that one now has 12. But what happens at the same time when I start to cut up more parts? That original 1/4 has changed not into 1/12, but into 1, 2, 3 twelfths. This 1/3, while it was 1 part out of 3, when I've cut it into 12, it actually represents 1, 2, 3, 4 parts out of 12. Okay, because that original third's been cut up into even more pieces. I haven't changed the size of my pizza, I've just cut it into more parts. And that together, 4 twelfths plus 3 twelfths, can give me 7 twelfths. So there is a way to compare them. Let's have a look. Now, obviously, I can't spend my life drawing diagrams, so let's have a look at what that actually looks like mathematically. Okay, let's have a look at some same examples first, just really quickly. Okay, I said the first thing I've done is I know I'm adding fractions. They all have 11 parts that make up a whole. I've got one pizza with 3 out of 11, one with 5 out of 11, and one with 6 out of 11. Okay, so 11 parts is going to make up my whole. So 11 is going to be on the bottom. And then in order to work out how many parts I have left, I go 3 plus 5 plus 6. So that becomes 14 parts out of 11. 2 ways to write this one though, guys. 14 parts out of 11. That has a bigger number on the top than it does on the bottom. So I call this guy an improper fraction. Now there's something cool I remember about improper fractions, and I remember that I can actually convert them to a mixed numeral. So if I have 14 parts and 11 parts make up a whole, that gives me at least 1 whole and 3 parts out of 11. Now, how did I get that? I asked myself, how many times does 11 go into the top number? Because 11 parts will make up a whole. Okay, that's once. And there was 3 remainder. And I know 11 parts make up my whole, so that's going to be my denominator. And my leftover is going to be my numerator. Okay, that's that one. That's pretty straightforward, pretty simple. Okay, let's have a look at another example. Let's look at a subtraction one. I have 7 over 9, subtract 2 over 9. So I know that 9 parts make up my whole. I've had this conversation lots and lots. 9 parts make up my whole. 7 over 9 minus 2 over 9 will give me 5 over 9. Okay, 9 parts make up my whole, and I had 7 over the 9, and I'm subtracting 2 over the 9, which will give me 5 over 9. Uh-oh. What happens now? What happens now when I have an example of, say, maybe 1 over 5 plus a half? I've got something that's split into 5 parts and I've got something that's split into 2 parts. Now, how do I work out what is the common number between them? Well, I'm actually looking to find the lowest common denominator. And one way I can do that is I can start writing the multiples of 5 and the multiples of 2 and see which one's in common. So the multiples of 5 are 5, 10, 15, 20, 25. I like to write the first 5 of each first. And if I don't get any hits after that, I keep on going. So 30, 35, 40, 45, 50, etc. until I find a similar one. Okay, let's write the ones for 2. 2, 4, 6, 8, 10. I could go 12. Okay, whoa. Hold up. I've noticed that 5 times 2 is 10 and 2 times 5 is 10. So I have a common number there, okay? I've written my multiples list and I have a common number. What I can do to these two is I can put them as a fraction over 10. I can find an equivalent fraction, okay? So I'm going to put them both over 10. And what I have to ask myself is, what have I done to that 5 to get 10? What have I multiplied it by? Oh, well, I've multiplied it by 2. I know when finding equivalent fractions, if I multiply the bottom by a certain number, I must also multiply the top. If I multiply the bottom by a certain number, I must also multiply the top. So, if I multiply the bottom by 2, I multiply the top by 2. Okay, so 2 times 1, now that I'm modifying the top, is 2. With the 2, what have I done to get the 2 to 10? Oh, well, of course, I've multiplied it by 5. I can tell here because that's 1, 2, 3, 4, 5. I multiply the 2 by 5 to make it equivalent. I must multiply the top by 5. Okay, so 1 times 5 is 5. So I can write a half as 5 over 10, and I can write a fifth as 2 over 10. They're equivalent fractions. So now, look what I've got. The same count of parts. I have 2 parts out of 10 and 5 parts out of 10, which gives me a total of 7 parts out of 10. Pretty straightforward, hey guys? Let's have a look at one more example now we've got the principles. Okay, let's get rid of this and rid of this, rid of this. Okay, now we've got the principles. Let's speed up. Okay, cool. 3/4 plus 5/6. My multiples of 4 and 6. I need to find something because these two here are not common. The bottom, my denominators, aren't the same. So let's go. 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16. 6 1s are 6, 6 2s are 12, 6 3, oh, there we go, automatically found one. I've got a 12 in this column and I've got a 12 in that column. Okay, if I have a 12 in each column, that means 12 can be my common denominator. So I'm going to go 12 here plus 12 here. See how I already established that? I always do that first. Then I ask myself the question, what have I done from 4 to get to 12? Oh, well, I've multiplied it by 3. I've gone 1, 2, 3. If I multiply the bottom by 3 to get to 12, I must multiply the top as well. So 3 3s become 9. So another way to write 3/4 is 9/12. This one here, what have I done from 6 to get to 12? Well, of course, multiplied it by 2. If I multiply the top by 2, I must multiply the bottom by 2, I must multiply the top. Again, this time, whoa, same denominators, excellent, which means my answer is going to be some parts out of 12, 9 plus 10 is 19. Ooh, interesting again, 19 over 12. It's more than one whole. 12 parts make up my whole and I've got 19 of them. So I'm going to have the equivalent of one whole. And what's the difference? Okay, if 12 parts make up a whole and I've got 19, that's 1, 12, 13, 14, 15, 16, 17, 18, 19. 1 and 7 on 12. It's my final answer. Always make sure you simplify. Okay. Cool. Screaming through here, guys. Last one. Hey, isn't that interesting? Same question again. Well, no, sorry, different question. Same denominators. So I already know the answer. But let me show you what this will look like when you do subtraction. Okay? I know my common denominator is 12 because I just had 6 and 4 in my last question. If I've multiplied 6 by 2 to get to 12, I must do the same to the top. If I've multiplied 4 by 3 to get to 12, what I do to the bottom, I do to the top. So 2 times 5 is 10. 1 times 3 is 3. So another way of writing 5/6 is 10/12. Another way of writing a quarter is 3/12. So 10/12 minus 3/12 becomes 7. Sorry, I'm going to go over here. 7/12. Exactly the same way to write it. Okay, lucky last but not least. Adding and subtracting mixed numerals. Okay, adding and subtracting mixed numerals. Let's have a look at these bad boys. It's saying 3 2/3 plus 4 2/3. The cool thing I can do here is I can separate my whole numbers and my fractions. So I can say, okay, I've got 3 plus 4 plus 2/3 plus 2/3. So what I'm going to do for the moment is I'm actually just going to leave the whole numbers out. Okay, I'm going to come back to them at the end. I'm going to say, okay, what's 2/3 plus 2/3? Cool. Same denominator on the bottom. Makes life super, super easy. Excellent. I've got 2/3 plus 2/3. Oh, that's easy. That's 4/3. Ooh, but wait. 4/3. That's the same as saying 1 1/3. Okay, so that's my answer for my fractions. They come together as 1 1/3. I've got 3 plus 4 plus 1 1/3. 3 plus 4 is 7, plus 1/3 is 8 1/3. Okay, so you are able to separate the numbers and then the fractions. Okay, let's have a look at another example. I'm going to show you another way you can do it in a moment. Okay, let's look at this guy. Okay, let's have a look at him. 2 5/6 and 3 3/4. Okay, again, I'm going to leave my numbers out. Okay, I'm going to leave my 2 and my 3, my whole numbers. I'm going to leave them out for the moment. And we're looking at 5/6 plus 3/4. Okay, so I've just grabbed these guys here. I've left my whole numbers out because I'll add them at the end. Ooh, oopsie daisies. Look at our problem. Don't have the same denominator. I'm showing you similar kind of numbers so you guys get used to it so I don't have to waste my time. You know that the common denominator for this one's going to be 12 because we've just done this about 10 times. 6 and 4 is 12. Okay, what have I done to 6? I've timesed it by 2, which means I times the top by 2. What have I done from 4 to get to 12? Timesed it by 3, so I do the same thing again. 5 times 2 is 10/12, is another way of writing 5/6. Another way of writing 3/4 is 9/12. Okay, so the answer for this one with my fractions becomes 19. So 10 plus 12 plus 9 on 12 becomes 19 on 12. Or 1 and 7 on 12. So I've got 1 and 7 on 12. This is my grand total. 2 plus 3 plus 1 and 7 on 12. So that's 2, 3, 5, 6, and 7 on 12. Simple as that. Okay? I know I'm racing through a little bit, guys. If you want to take this one back a notch and watch it again, that might be a good idea. Okay. Next. Okay. First off, let's have a look. Okay. 2/3 minus 1/4. 2/3 minus 1/4. Don't have a common denominator. Let's look at my numbers. I've got my multiples of 3. I'm only going to do it in my head. I'm not going to write them down this time. You might want to write them down. 3, 6, 9, 12. Okay. And I know 4 is a multiple of 12 as well. So I'm going to go with my denominators of 12 again. Okay. What have I done to 3 to get to 12? I've timesed it by 4. If I times the bottom by 4, I times the top by 4. 2/3 I can also write as 8/12. Okay, this one here, what have I done from 4 to get to 12? I've times it by 3. So to find an equivalent fraction for a quarter that's over 12 would be 3 over 12. So 8 over 12 minus 3 over 12, sweet, easy, easy peasy Japanesey, that becomes 5 on 12. Awesome. I've got 5 on 12, that's one fraction, subtract another fraction. This time I need to deal with my numbers. So what's 5? Whoops, sorry, I wrote the wrong number first. Okay, what's 5? Subtract 3. Oh, sweet, easy, that's 2. Okay, so my numbers give me 2, and my fraction gives me 5/12. Therefore, this is what these 3 dots mean. The answer for this is 2 and 5/12. 2 and 5/12. Okay, let's look at another one. Last one. Sorry, I was just getting excited. It was the last one because my voice is hurting. Sorry, it was horrible. Let's have a look at this bad boy. 8 1/5 minus 4 3/4. Okay, let's have a look at this delightful little number. Before I look at it, let's just look what I got. With my fractions, I've got a 5th minus 3/4. What? A 5th minus 3/4? What the hell? Doesn't really make sense. Now, there's a few ways you can do this. There's this whole weird borrowing a whole thing. What it says is that 8 1/5, the 1/5 bit, I can also write that as 7 6/5. Okay. How did I get that? Well, 5 parts make up a whole. So I can assume from here we have 8 parts of 5 and a part that's got 1 out of the 5. Okay, I know because 5 makes up a whole. So I can technically say I have 7 6/5. This 6/5 is now an improper fraction. Okay, I can then say, all right, okay. If that's got 6/5, I can then subtract 3/4 from it because I know that 6/5 is bigger than 3/4. Okay, so we'll roll with this borrowing the whole thing first and see how you guys like it. Okay, 6/5 minus 3/4. Yo, can't do it. Problemo, because my numerators aren't the same. Lowest common denominator with 5 and 4. Let's do them. 5, 10, 15, 20. Oh, someone's being chased by the police in my suburb. This is exciting. They're my multiples of 5. 4 1's 4, 4 2's are 8, 4 3's are 12, 4 4's are 16. Still haven't come up with anything. 4 5's are 20. Hey, there we go. 20 on that one, 20 on this one. So my common number that 5 and 4 go into is 20. 20 here, subtract 20 there. Now, what have I done to 5 to get to 20? Well, I've multiplied it by 4. If I multiply the bottom by 4, must multiply the top by 4. So 6 4's are 24. What have I done from 4 to get to 20? I'll do it in a different colour. Well, I multiplied it by 5. If I multiply the bottom by 5, must multiply the top by 5. Sorry, this is now getting a bit messy. That becomes 15. So let me just rub this out so I've got some room. 15. So another way of writing 3/4 is 15 over 20. Now I'm left with 24 over 20. Subtract 15 over 20. Okay, that leaves me with 9 over 20. Okay, but remember, I've borrowed a whole from here. So this is going to be 7. 7 subtract 4 leaves me with 3 and 9 over 20. Okay, that's one way you can do it when you have a smaller denominator at the start. Another way you can do it, okay, another way if you want to sit and have a little ponder, I know that mixed numerals and improper fractions are the same way of representing, are two different ways of representing the same thing. Okay, I know that. I've learnt that. I'm happy with that. So I can actually change them into improper fractions and try that way. Okay, so I go, how do I do that? Let's remember how to change a mixed numeral into an improper fraction. 8 times 5 is 40, plus 1 is 41 on 5. 4 times 4 is 16, plus 3, 16 plus 3 is 19 on 4. Okay, then I have not 41 on 5, subtract 19 on 4. Same rules still apply like they did before. If I've got two fractions and I'm subtracting them, I need to find a common denominator. Okay, as I learnt before, my common denominator with 5 and 4 is 20. Please excuse me. If I've multiplied 5 by 4 to get 20, I multiply the top by 4. If I've multiplied 4 by 5 to get 20, I must do the same thing with the top. So it becomes 164 minus 95, which gives me an answer of, it gives me an answer of 69 on 20 when I work it out. How do I write 69 on 20 as a whole number? How many times does 20 go into 69? Well, 3 times, with the remainder of 9 on 20. See? Got the same answer. Two different ways of doing the same thing. And that's it, guys. That's adding and subtracting fractions.